I want to draw your attention to an important property of the direction of kinetic friction forces. So that's something that stumps students sometimes, so I want to talk about that. So let's say we have an object, and this object, we'll call it A, and this object is resting on another object B. All right. And I tell you that object B is actually not moving. So velocity of B is 0, while A is moving to the right. So let's say VA is equal to 5 meters per second. V is moving to the right with respect to B, and B is not moving. And I ask you, what is the direction of the kinetic friction force? You would have no trouble answering that question, because if you draw the free body diagram of A, you'll have the normal reaction, you'll have the weight, and you will have the friction force shown so that it is opposing the motion of A with respect to B, right? So in this case, there is absolutely no problem, because you can clearly see that the object is moving to the right, and that means the job of the kinetic friction force is to oppose that motion, so it'll be pointing in the opposite direction of the motion, right? Okay, now let me change this problem slightly, and I'll say that I have the same object A, which is still moving with 5 meters per second velocity to the right. Now the B over here is actually moving with a velocity of 3 meters per second. Okay, so now both of them are actually moving. A is moving to the right, B is also moving to the right. Now the question is, which way the friction force on A would point, right? So NA is still same, weight is still same, right? But the direction of the friction force, it seems now that becomes a slightly difficult question to answer. But if you remember that the job of the friction force is to oppose the relative motion. So relative motion is the key, right? So oppose, let me write that, oppose the relative motion, then you would have no problem figuring out the direction of the friction force. So let's look at the motion of A with respect to B, because our attention is on A, right? So what is the motion of A with respect to B? Motion of A with respect to B is actually still towards the right. Why? Because if you look at velocity of A with respect to B, and that tells you something about motion of A with respect to B, that is nothing but VA minus VB, and that quantity is 2 meters per second to the right, right? Which means that now B would still try to pull it in the opposite direction of this relative motion. And that means friction force, even in this case, would be pointing that way, right? Okay, now let's change this slightly more. So A is still moving at 5 meters per second, but B now is not moving at 3 meters per second, but it's actually moving at 8 meters per second to the right. Now what happens? Well, now you can see that velocity of A with respect to B, which is VA minus VB, is nothing but minus 3 meters per second, right? Which means that in terms of magnitude, it's 3 meters per second towards the left. So A is actually moving towards the left with respect to B, right? So this would be the direction of the friction force on A in this case. So you always have to look at the relative velocity, and that will tell you what the direction of friction force should be.